Good morning, good afternoon, good evening, good night, depending on when you're watching this video. So in this video, we will work through the exercise on slide 24 of lecture set 7. So we're going to be computing components of the margin of error in this particular example. In particular, we're going to focus on the components of the confidence interval. And in particular, we're going to focus on the margin of error. We're going to compare margins of errors for different confidence levels in terms of the accuracy of the interval that they would generate. And then we're going to do a sample size calculation based off of the margin of error. Okay, so we have here part A. So an SRS of size 7,356 is used to compute the monthly fuel expenditure in Canadian dollars per household. Suppose sigma equals $16.58. Determine the margin of error needed to estimate mu at the 99% significance level, or 99% confidence level. All right, so technically, this is more or less the same procedure that we would undertake with a confidence interval, in that in order to use these margins of error, we have to check off those same assumptions. Okay. So first assumption is that we collected a simple random sample, which is true based off of the interval. The second assumption is that X bar is normal. Okay, we can also check this off, and we can say in this case, by the central limit theorem, because our sample size is significantly greater than 30. Okay, and then the third thing we need to know is whether or not we have sigma, which in this case we do have. All right. Okay, so we'll call this 99% E. Okay, so capital E means margin of error. All right, so just like we would with a confidence interval, we need to find the Z-score. So we have 99% confidence level. This is going to mean that alpha is 1 minus 0.99, which is 0.01. So therefore, Z alpha over 2 is Z subscript 0.01 over 2, which is Z subscript 0.005. Okay. Okay, so here's our standard normal curve. Here is the Z-score that we are looking for. So this little tail area here is 0.005, which means that this area to the left of the Z-score we want is 0.995. If we go to our standard normal table, you can see that I actually already have this value highlighted. So 0.995 is exactly in between 0.9949 and 0.9951. So that is 2.575 because we can average this Z-score. So again, the 99% interval returns a value of 2.575. Okay. So then on step 2, we're going to compute the margin of error. So the margin of error is Z alpha over 2 multiplied by sigma divided by the square root of n. So you can see that the margin of error is actually just what's to the right of the plus minus symbol in the confidence interval formula. So we would typically have X bar plus or minus Z alpha over 2 multiplied by sigma over the square root of n. In this case, we're only computing the what's to the right of the plus minus. So this is going to be 2.575 multiplied by 16.58 over the square root of 7,356. And that gives us 0.498. Okay, part B says, given the same standard deviation, will the margin of error needed to estimate mu at the 95% confidence level be bigger or smaller than the one from A? Explain. All right, so in part B, basically what we have here is for fixed sample size, the margin of error increases with an increase in confidence level. Therefore, the margin of error for a 95% CI will be smaller than that of the 99% CI. Okay, so in part A, we constructed the margin of error for a 99% confidence interval. If we then consider a 95% interval, the margin of error is going to decrease because we are decreasing confidence level. So the size of the margin of error increases with the confidence level as long as sample size is held constant. And the standard deviation is constant as well, which it is in this case. Okay, part C, verify or answer. Okay, so in part C, we're just we're doing the exact same thing that we did in part A, except that we are changing to the 95% level. So the assumptions in that case will be exactly the same because there's nothing changing that would influence the assumption. The only thing we're changing is confidence level, and that does not influence the assumptions of our procedure at all. So these are exactly the same. Now we have 95% E. Okay, so on step 1, we have 95% confidence level. Okay, so that means alpha is 1 minus 0.95, which is 0.05. And that means Z 0.05 over 2. Or sorry. So then we would have Z alpha over 2 is equal to Z 0.05 over 2, which is Z 0.025. All right, so same process that we've seen up until this point. So here's our standard normal table. Here's Z 0.025. Okay, so now this area here is a size 0.025, which means that this thing is a size 0.975. If we go to our standard normal table, the area to the left of the Z score that we're looking for is 0.975. That's exactly equal to 0.9750. So the Z score for the 95% margin of error and the 95% confidence interval when sigma is known is 1.96. Okay, so then on step 2, we have E is equal to Z alpha over 2 multiplied by sigma over the square root of n. This is 1.96 multiplied by 16.58 over the square root of 7,356. Which is equal to 0.379. Okay. Okay, so we can see that this value is smaller than the margin of error given in part A, so therefore we have verified the results. So the result follows since 0.379 is less than 0.498. All right, and then in D, it says, what sample size is required to estimate the mean fuel expenditure within 25 cents of X bar at the 90% confidence level? All right, so in part D, we would have N is equal to Z alpha over 2 multiplied by sigma divided by E squared. Okay, we are working at the 90% confidence level here. Okay, so we need Z. So we're working at the 90% confidence level. So that means that alpha is equal to 1 minus 0.9, which is 0.1. So we have Z alpha over 2 equals Z 0.05. And we've seen this Z score a lot. So we know that the Z score for the 90% level when sigma is known is 1.645. Okay, so this is again, we are using 1.645 because we have a 90% confidence level. Okay, so we have 1.645 multiplied by 16.58. Sorry, that little dot means multiply as well. And this is going to be divided by 0.25 because we want to be within 25 cents. Okay, so we're trying to build a very accurate interval. Okay, so if we work this thing out, we're going to have N is equal to the square root of 109.0694, 109.06 or 0964 squared, which is 11,902.02. Okay, so therefore, we require N equals 11,903 observations. So whenever we compute a sample size, we always round up, no matter what the value is. In this case, you can see we have 11,902.02, but we still round it up to 11,903. We don't round down when we compute sample size, because if we round down, there's a possibility we miss our goal, which in this case is to estimate the fuel expenditure within 25 cents. Okay, so regardless of the value that comes out, we always round up. Okay, as always, if you have any other questions, please let me know.